Thank you again, Shannon, for the invitation. It's a really pleasure also to be here. And I will share my screen also. So I hope in the next couple of minutes, I also can actually, I would like to invite you to come here to Portugal to visit us. And also to know a little bit more what we are doing for the digitalization of the agriculture. So I know that thematic is about the soil. So what I'm going to talk about is how can we use these smart technologies to produce and also to have a more efficient agri-food production, including the taking care of the soil and also to monitor these potentialities of the soil in pro of the best ways of the agriculture production. So the first of all, for you to introduce what are these figures of collaborative laboratories. So this is a network that exists in Portugal. So Portugal is really small when we compare with the US, but we are really also strong, and we have a great not only in technology but also in scientific approaches. So these collaborative laboratories was created a few years ago by the Portuguese Ministry of the Science and Technology, and also a foundation for the scientific and also technology in Portugal. And what it aims is also to connect the academia, so the universities, and the industry. So the differences in the industry that can be the agro sector, can be, for example, the construction, the climate, and so on. So all these collaborative laboratories, the main mission is the transfer of the scientific and technology knowledge from the academia to the industry by decreasing what we call the gap that exists between these two worlds, if we can say that like this word. So in Portugal, there are currently 42 entities that have this seal of collaborative laboratories, and they are divided in different thematic areas that are, for example, for the agri-food, the health, biodiversity, oceans, social services, tourism, etc. And among them, there are one thematic areas that we call the agri-food. And here, there are other entities that have other specializations, and we can record that the Smart Farm Colab is over here. And so in Portugal, if we look into the map of the Portugal, Smart Farm Colab is not far away from Lisbon. So we are here close by Lisbon. So that's the reason why I also invite you to come. There's a very close to us, the airport. They have the direct flights to US. So please, when we come to Lisbon, don't hesitate to contact us. And we'll be a really pleasure also to receive you in our facilities. So, after this small introduction, so Smart Farm Colab is one collaborative laboratory, and among them that we works in the agri-food thematic area, ours is the only one that works in the digital innovation in agriculture. So our entity is classified as an association, so we are a non-profit entity. We only focus on the services for the digitalization of the agriculture, and in particular, this democratization and also literacy of the agriculture 4.0. So we have also our thematic areas focus on high TRL. So we are all our services in all our activities are around TRL 5 and TRL 8. And our main goal is also what we call in terms of the co-creation of innovative solutions and customized solutions for the agri-sector. So as I said before, as we are an association and as we have this mission of the transfer of scientific and technology knowledge from academia to the industry, so our model is based in what we call a helix quadruple entity, in which we have for one side entities that are more connected with the policy uptake. And we can say that our members, so far we have 15 members. This is also one of the rules that the ministry, the Portuguese ministry, also have for the collaborative laboratories. And so in these 15 members, we have the municipality, that is the Torres Vedras municipality, but then we have different entities related with the academia and also research laboratories, but also we have entities related with the companies, so SMEs. And in the SMEs, we have some of them that I think that you know, because they have a worldwide they have a worldwide specification like SGS that is present in different sectors and actuate in different sectors. But then we have different ones that have, for example, that works in technologies or in spray technologies, in software technologies, the production system, and so on. So like this, we can have all the entities involved and also the society, and we can have the bridge between academia and then the industry. So in terms of agenda, as I said before, we have this transfer of technology and also knowledge system, but in which harms that we operate are basically not only the smart technologies, but also in smart data, because as I said, we are on the digitalization of the agriculture, and we can never dissociate technologies with the data. And when we look into this roadmap, our main focus are two. Basically, we are on the development of inclusive technologies for the agriculture. And the second one, to provide the technical support needed to adopt these technologies. Why? Because we believe like in this way, we can have what we call a best transition in the digitalization of the agro sector. And so like this is our axis that we are operating. So smart technologies by the identification of needs and gaps, and by developing customized solutions, the data, that means develop ecosystem of applications that make sense for the needs of the agro sector, and also to promote the support decision-making process, and then to transfer all this knowledge into the production ecosystem. Why? Because we need to maximize the use of these digital technologies and their also adoption. For sure, we have also to survive, so we need to develop business services, and these business services are developed for the industry and to promote the capacity actions and training. And normally, all these actions are performed in terms of customized always solutions. So are some photos that are always present in our dailies. And so we see all the time a lot of robots, a lot of different machines that helps the farmers and also the production to be highly productive and also to be more sustainable. And so to perform all of this, that is not new, we still need to do a lot of work. And one of them is this digital transition. And so what we saw, for example, in the Portuguese reality and also the European reality, is that our farmers and agriculture production, so the people that is involved, have a high age. And sometimes these technologies are not, or the majority of the time, the technologies are not accessible to all of them. And so we need to put these technologies affordable to all the farmers. And so we have been developing since our existence a low-cost modular sensing technologies. In this case, we call it SOFI, so Smart Orchard Fertirrigation Systems. And what is this? These are basically customized solutions that we first assess and we identify the need, and then we design the solution. Normally, I said that solution is not beautiful, the solution is useful. And this is a great difference between useful and beautiful. And so all these solutions need to be real-time monitoring. And so we have different remote communications protocol that we have been developed, and always try to decrease always the price of the solution in the end, and to get it the useful information for the farmers. So this is our example of the R&D that we have been developed with one of our members and partners, that is INIAV. This is a Portuguese institute for the research in terms of the agriculture. And so this is really important. Why? Because we have calibrated and also validated the low-cost sensors, that is technology that we are developing, that is SOFIS, with the sensors of reference. And so like this, we can know exactly, and with the robustness, that the technology that we are using actually it's a real, and we can trust in the data that we are having in the field. So this is the pipeline. Sorry, it's in Portuguese, but I will translate so the pipeline that we have. So this is in the field. So what we have is the proximal sensing installed. So this is an example of what is the SOFIS. All this data is then connected and sent to process the data, so a IoT server. And then the data can be analyzed into a platform, an interactive platform, in which the farmer can get the decision, so we can get the support to take the final decision. So this is what we have already developed, and always please take in consideration that this is affordable technology, because this is already there's commercial entities that have this all approach and in the market. So we are not on the market, we are on the transfer of the scientific and also the technology knowledge. And so in the future, this is what we want. So it's to have the machine communicated with the machines, for example, to control the irrigation step or other processes that are needed in the daily basis management of the farmers. So this is an example if you want to look into the QR code. So previously, before the meeting, I was looking, and this is working. So what is going on, for example, in a meteorological station that we have installed in our facilities? This is an open source data, so you can always have this data if you want to check what is going on in Portugal, in particular in Torres Vedras, where we are located. So the best way to exemplify how this technology is using, it's, for example, I will take two practical use cases. I hope that we enjoyed these two use cases. So one of them is the crop monitoring. And here what we use, it was a different kind of sensors. So we have sap flow sensors that will analyze the sap flow of the plants, and also the vapor pressure deficit. And together with this MLI that will help us to estimate the soil evaporation. So all of these ones were installed in olive crops. Why? Because what we want is to estimate the real crop water requirements. And based on this was installed in the university in Lisbon, that is ISA, Instituto Superior de Agronomia. And with this, we want to estimate exactly the crop water requirements, because we know that water is a real problem, and it's a limited resource that we have. So another use case is the project from Terceira Azores Island. So this is a very beautiful also Portuguese island in the Azores. And we have a project over there. So the project have more or less 2 years so far. So the main goal of this project was started, for example, this is a very nice story, because the real goal of the project started to use a remote communication that was installed in the island, that is the LoRa communication. And normally the municipality of the island uses this remote communication to monitor the boats that were close by the island. And so then, because the farmers started to abandon the production in the island, we said, okay, let's put a little bit of technology also to bring farmers and to attract farmers to this region, in particular for the vineyard production. And so like this, we have installed different technologies, so pilot technologies, in this case, the SOFIS. And the goal that we started to think, and the mission, it was to develop an automatic alert and also a visualization system, in particular for two diseases of interest. In this case, the mildew and powdery mildew in vineyards. And for this, we have installed 4 meteorological stations in 4 producers. And so we have different proximal technology installed. And also we are collecting drones images in these areas, and also satellites. So we are combining the both of satellites and drones. One is because of resolution, so for sure, but also because in the Azores Island, we can get the sun, and 5 minutes later we have a lot of rain, and it's impossible to get data from the cloudy, let's say, days in Azores. So this is the kind of vines that we are talking about. So the normal vines that normally we know already, the line vineyards, and the another ones that are protected into the stone walls. So we have the stone walls that in Portuguese we call currais, and then we have very, very little and tiny vineyards inside that sometimes we can think that are weeds, but are not. These are really plants, and we saw that when they are growing. And so what we installed, it was these meteorological stations, low-cost meteorological stations, to collect the microclimate, so they are at the same size of the vineyards, to get this microclimate from the plants. So we know that Azores Islands is a unique wine region, so they have also very interesting wines to taste. It's a meritic, there's an Atlantic influence. This is a volcanic soil, they are very particular kind of the wine, and they still have this traditional vineyard production in small stone walls in different varieties, and these ones, they have 3 particular varieties that are the most important. And actually this micro terroir and unique wine region make us in particular study, because this is really interesting and what we want also to show. So this is the region that we have installed the sophies. So the vineyards are very, very, very little and very, very fragmented, which is very, very difficult also to get to work on that. So we have here, so imagine that these are in different altitudes, so in different heights in the island. So here we have installed the first one, the sophies number 1 at 100 meters. Then we go a little bit less, say, to 65 meters, and we have more 2 systems in the field. And then very close to the sea at 35 meters, we have the 4th system installed. And so what we were looking, it was, okay, so the first thing is, if we compare the normal vines that we know, and sorry to say normal, like say line vineyards, as we know normally that they are producing, with, for example, the other ones that are protected for the stone walls, there's a difference in temperatures. This will, for example, impact in terms of the maturation of the vines. And so we were starting to analyze a little bit the results and also the proximity into the sea. And what we see is, in fact, for example, if we compare the 100 meters up to the 35 meters, okay, we have an impact for sure of the altitude in terms of the temperature, but also if we compare, for example, the stone walls, we see that effectively the temperature is higher when we have these stone walls, and we are thinking about more or less 1.2 degrees of differences. So we have more 1.2 degrees when we have these grapevines produced within the stone walls, which before the farmers know that temperature was higher, but they didn't have an idea in terms of the mean of these temperatures. So this is the data from July. And it also is interesting because in terms of humidity, from the line vineyards compared with the vineyards within the stone, we have a differences of the 2.9 in terms of the humidity. And then in terms of, if we long, for example, from July to October, for example, this is a random data, we still have the same. So the temperature is always higher when we have these stone walls. So then We are still analyzing these results and also to include the powdery and powdery mildew in terms of the alerts. So I hope, for example, in the next webinar and next sections, I can also share you more information, and also to share in our LinkedIn, because I think that these are results that could be interesting for other viticulture production. So this is maybe more interesting for the webinar of today, because a part of the technology, we would also know what is this micro terroir that makes so special the vineyards and the wine from these islands, these volcanic islands. And so also in the 2023 campaign, we have performed a microbiome analysis of these vineyards, so to analyze this wine terroir. So this was performed with a company that is also based in US, in Sacramento, that is Biomakers. And so what we did, it was a study in the terms of genetics for 4 phenological stages. So in dormancy, bud burst, harvest, and dormancy. And always for the same, for sure, vineyards. And so what we compare, it was the training system. So the normal, as I said before, normal vineyards that we know, the linear vineyards with the stone walls. And in fact, it was surprising because we see that in terms of, if we look into the soil quality, this is the timeline. So dormancy, bud burst, and harvest. And this is the difference ones from the line vineyards into the stone walls from this 100 meters to 35. And so what we saw, it's, for example, in terms of the biodiversity of the soil, we have higher diversity in terms of the traditional vineyards when compared with the line vineyards, in particular also in the lower altitudes. And this biodiversity and functionality also have an inversional proportional relation between them. And curiously, but this is something that we were expecting, is that the vineyards that are closer to the sea, to the ocean, to the sea, they have a higher resilience. And we know that salinity is one of the problems, and that's the reason why we have microbial communities that are, I would say, like a squad into this microbiome to protect the vineyards against desalinity, for example, from the ocean. So this is our some microbial communities of interest that can make and translate also in this wine terroir and this specificity. So we have different, for example, in this case, Saccharomyces or wine potential microorganisms, and also with salt resistant. We can't forget that we are really very, very close to the ocean. But then we have also a problematic and or some bacteria that could have this acetic acid that could be that needs to be protected also and influenced in terms of the wines. So just to jump, and I hope I'm not controlling the time, but I will finish in some minutes. So just to take you into another action. So as to recap, we were talking about crop monitoring by using, in this particular case, the sensoring technology. And so we can apply for the soils, we can apply for the crops monitoring and to have this relation for example, for the water crop requirements. But another part is, for example, the robotics and automation. So we were challenging by the farmers from the Portuguese, so from the region that we are in, to develop accessible solutions, in this case, a robot, a modular and configurable robot to, in this case, to identify and also to collect, to pick tomatoes in greenhouses. Because why? Because the manpower is a problem in our region. And so this was a challenging from the farmers, and we get the project on that. So what we have developed, so the entity leader of the project is a sprayer company. So what we have developed, sorry, it's have sound, it's off now. So it was a robot that is an autonomous and also configurable robot that identifies the fruits, in this case, tomatoes. And when identifies not only the tomato, counts the fruits that exist in the greenhouses, but also will collect according to the ripening stage of interest in this case and the size of the fruit. And then they can, after collect, so here is not collecting because it's an exposition, then it can put the tomato in the box if we say, okay, this is the size A or size B, and we want you to collect this and this and that. So this robot was awarded a few months ago with an innovation prize from the farmers from our region. And because of that, and also because this was something interesting, and the farmers were also asking for these technologies. So we are now in the second project that is a Tech for Green. This is a Portuguese and national project. And what we are developing is also using the robot, so the vehicle that can push the equipments that are behind the robot, the configurable robot. So now we are putting intelligent spray management, in which what is the main goal? It's to have a real-time prescription of, in this case, the products, the production factors, and only to a selective spraying with a technology, in particular technology to spray, in this case, tomatoes in greenhouses. But what we are doing in this project is going into the orchards, in the pears, and also apples. Just to conclude, so okay, we can have a lot of different technologies, but if we don't have trainings, if we don't have showcases, if we don't have dissemination of these technologies, it will be really hard to get this digital transition. And so what we are doing, one of the most impact that we have doing in the agro sector is to promote different training in workshops, in the particular for specializing training support. So we have developing different workshops, and these workshops are performed by demand according to thematic areas that the entities needed. Trainings, in particular for the Agriculture 4.0, open days, and here in particular with students and agro-professional schools, and also different events. We have one that is the Forum Agriculture 4.0 that is the sixth year that we have this event that is normally in the end of June and July. So you are all also invited to come and to participate in these events. And so I hope that I not speak too much today. Sorry, Shannon, if I do it. And I finish my presentation, and thank you so much.